Hello everyone, welcome to Dakshana e-classroom program. In today's video lecture, I will be discussing the solution of DT09 NEET paper for part physics. So I hope everyone tried their best in the exam, and after exam, another important point is to learn the mistakes or to learn the questions which you were not able to solve in the exam. So I hope after going through this video, you will be in position to understand the solution of those problems which you were not able to solve in your exam. Okay, so let me start with question number 1. A current loop consisting of two identical semicircular each of radius capital R, one lying in XY plane, another in XZ plane. If the current in the loop is I, the resulting magnetic field due to the two semicircular part at their common center. Okay, so here let's say this is the X, Y and Z axis. This is XY plane, then one loop is lying in this, let's say radius, and carrying current I. Another loop is lying in this plane, X Z plane basically. So I have taken that this is in XZ plane. So magnetic field due to this will be in this direction, let's say B1, and magnetic field due to this if current in this direction. And we know actually B due to semicircle at center. So this is given by mu naught into I divided by 4R. And direction we can find it by right hand thumb rule. So B1 in this direction and B2, let's say this is B1 in this direction and B2 will be downward. Then these two are mutually perpendicular, so definitely, and because current is same, radius is same, so I can write B1 will be equal to B2 and B resultant will be equal to B1 root 2. And this implies it's because only magnitude is asked here, so mu naught into I root 2 divided by 4R, and that comes out to be mu naught into I divided by 2 root 2R, and that matches with option 1. So this is question number 1. Next, question number 2. Two parallel metal plates having charge plus Q and minus Q face each other at a certain distance between them. If the plates are now dipped in kerosene oil tank, the electric field between the plates will be. So we know actually two parallel plate, this the charge plus Q and minus Q. So now right now the air, the space is between the plates is filled by air. So electric field we know E is given by Q by A epsilon naught. Is it? And when some medium is filled of dielectric, if dielectric K is inserted, then E prime become E naught by K. And when kerosene oil is filled, so definitely kerosene oil is a dielectric medium with some dielectric constant K, then E will become E naught divided by K, and always K is greater than 1, is it, except air medium. So definitely I can say when kerosene oil is filled, the K will increase, so electric field will decrease. So option here matches with 3. Question number 3. Electric field at a distance of 3R by 2 from the center of the charged conducting spherical cell of radius R. So charged conducting, let's say charged conducting cell of radius capital R. So electric field at this distance 3R by 2, this is given as E. Charged conducting spherical cell. Electric field at a distance R by 2 from the center of this. So this point is R by 2 lying inside, and we know actually electric field inside a conducting spherical cell is always 0. So that's why here E will be 0, and that matches with option 1, that is 0. Next, question number 4. When monochromatic radiation of intensity I fall on metal surface, the number of photoelectrons and their maximum kinetic energy. So number of intensity I, number of photoelectrons emitted, that can be written as N, and maximum kinetic energy, that is given as T, right? And we must know that on what factor N depends and exactly with what factor T depends, is it? So now if intensity of radiation is increased to 2I, if intensity is made now 2I. Intensity means number of, like you can say, energy striking per unit area per unit time. Intensity is becoming higher means more number of photons will be striking. So definitely I can write, compared to the I intensity, now 2I intensity, the number of photons striking per unit area per unit time right now has become double. So photoelectrons emitted will become 2 on, and the kinetic energy, maximum kinetic energy, depends on the frequency, and it's saying if intensity of radiation is 2I, the number of emitted electrons and their maximum kinetic energy are respectively. So because frequency, no change is happening here. Yes, if frequency change is happening, then kinetic energy or maximum kinetic energy will also change. So right now intensity is made double, means more number of photons are striking, and that's because compared to the first case it's double, so the maximum kinetic energy will remain same. This will be the answer, and that matches with option 2. Question number 5. The speed of light in medium m1 and m2 are this and this. So let's say this is medium m1, m2, speed of light v1 and v2, and we know refractive index mu is given by c by v1 and mu2 is given by c by v2. This is mu2 and mu1. Now what it's saying is that a ray of light enter from medium m1 to m2 at an incident angle I. So a ray of light entering from medium, this is angle of incidence m1 to m2 at an angle of, if ray suffer total internal reflection, that means this is the TIR condition, right? This is what happening. All right, the value of I, so this is a critical angle, it must be. Then what I can write, this is mu1 sine I should be equal to what, mu2 into sine 90 degree. Clear? And this implies sine I critical is coming out to be, this is 1 mu2 by mu1, and mu2 mu1 can be written as, this is c by v2 divided by c by v1. This comes out to be v1 by v2, and that is given as 1.5. v1 is 1.5 divided by, this is 1.5 into 10 to the power 6, 8 divided by 2 into 10 to the power 8, so cancel out, and this is 3 by 4. So this implies IC is equal to what, sine inverse 3 by 4. This is the critical angle, and we know for TIR to happen, the angle of incidence must be greater than critical angle. So that means the critical angle of incidence must be greater than this angle of, greater than sine inverse 3 by 4. So that matches your option number 3 for question number 5. Okay, next question number 6. A ray of light is incident on a 60-degree prism at the minimum deviation position. So the angle of prism is given as, this is given as A equal to 60 degree, and ray is incident such that it's going through minimum deviation, and we know the condition of minimum deviation, it happened when the ray inside the prism is parallel to the base, right, of the prism. So this is the condition. And now what it's saying, the angle of refraction at the first phase, angle of refraction means it's asking about this R1, and we know actually for minimum deviation R1 is equal to what, R2, this is R2, and we also know the condition that R1 plus R2 is equal to A, that is equal to 60 degree, and this implies 2R1 is equal to 60 degree and R1 is equal to 30 degree. This is the angle of refraction at first surface, and that comes out to be 30 degree. That matches with option 2. Question number 7. A closely wound solenoid of 200 turns. Solenoid. Total number of turns are 2. It's given as 2000. Area of cross section is given as 1.5 into 10 to the power minus 4 meter square. Area of cross section of the solenoid carries a current of I equal to 2 ampere. It is suspended through its center and perpendicular to its length, allowing it to turn in horizontal plane in a uniform magnetic field. So this solenoid, you can consider it like this. and this solenoid is suspended through like this is suspended in this manner. This is axis of solenoid, and allowing it to turn in a horizontal plane in a uniform magnetic field of B. B is given as 5 into 10 raised to power minus 2 Tesla magnetic field, making an angle of 30 degree with the axis of solenoid. So B is making an angle of 30 degree. This is 30 degree and this is B. Okay, axis. Then torque on the solenoid. So we must know here tau. So tau, how we get tau? So first thing is solenoid will act like a magnetic movement, is it, or magnetic dipole. Then magnetic moment of solenoid is given by m is equal to n I into A. N is 2000 multiplied by I is 2 multiplied by A is 1.5 into 10 raised to power minus 4. So this is your M, and then tau is given by M cross B, and that is equal to MB sine 30 degree. Simplifying it, so this is 4000 multiplied by 1.5 into 10 raised to power minus 4 multiplied by B, that is 5 into 10 raised to power minus 2 multiplied by sine 30, that is 1 by 2. So power, like, it comes out to be minus 6, and 5 into 4, that comes out to be 20. One more, this 2 gone, and 4, so this is also like gone, and it comes out to be 7.5 into 10 raised to power minus 2, and just 1 second, here magnetic, let me just check the calculation part here. Okay, just one, I did mistake here actually. So multiplying like this, and just let me substitute it here, multiplying these two, then we are getting it 4, and then actually I did 4 multiplication with 5, then I wrote it actually 20. So 20, and then these 3 zeros multiplied by 10 raised to power minus 4 into 10 raised to power minus 2, 5 is also gone, 5 into 4, this is an half. Now this 2 gone, and this 1.5 is also there, 1.5, this comes out to 1.5 into 10 to the power minus 2, this is Newton meter, that is the torque acting on the solenoid, and this is the answer to problem number 7, power minus 2. Next, question number 8. Decay constant of a radioisotope is lambda. So decay constant is given as lambda, and A1 and A2 are activities at time T1 and T2 respectively, number of nuclei which have decayed during the time interval T2 minus T1. So let number of active nuclei at T1 is, let's say, N1. Then what I can write, activity is given by dN by dt, this is equal to lambda times N1, right? And similarly at time T2 I can write A2 is given by dN by dt, that is equal to lambda N2. This is number of active nuclei at T1, number of active nuclei at T2. So number of, this implies I can write N1 is given by A1 by lambda, and N2 is given by A2 by lambda. Then number of active nuclei or number of nuclei decayed from T1 to T2 is, or T2 minus T1. So number of nuclei decayed in interval T2 minus T1, that is equal to what? N1 minus N2, and this comes out to be A1 minus A2 divided by lambda, and this is the answer which matches with option number 3. Question number 9. A particle having a mass of the particle is given as 10 to the power minus 2 kg, and charge of the particle is 5 into 10 to the power minus 8 coulomb. In gravity free space, the particle is given an initial horizontal velocity of b is given as 10 to the power 5 meter per second horizontal velocity, in the presence of electric field E, magnetic field B. To keep the particle moving in a straight line, it is necessary. So here we need to check for the different possibilities. So one thing comes is that if electric field, magnetic field, B, E and velocity all are in same direction, then magnetic force by force by magnetic field will be zero on the charged particle, because V and B are parallel. Electric force will simply keep on either accelerating it and decelerating it. So in that case, particle will definitely move in simply horizontal direction, or basically in one straight line. So this is what exactly, to keep the particle moving in straight line, it is necessary that B bar should be perpendicular to the direction of the velocity and E should be along the direction of velocity. If B is perpendicular and E is along, in that case it's never possible that particle will be moving in a straight line. Both E and V should be along the direction of velocity. That makes sense, possibility. Both E and V are mutually perpendicular and perpendicular to the direction of velocity. In that case also one situation happen. Let's say E bar is this way and B bar is this and V bar is this. That is option like C. There also comes one possibility, if electric force exactly balances or cancel the magnetic force, then also the particle can move with constant, move in straight line. So second and third both seem like both are right. B should be along direction of velocity and E should be along, no, that's not possible. So the best answer here matches with third, that is basically second and third statement makes possibility of particle moving in straight line. The binding energy per nucleon in deuterium, that is question number 10. So okay, the binding energy per nucleon in deuterium and helium nuclei are: deuterium binding energy, it's 1.1 MeV. Binding energy BePn, for deuterium it's 1.1 MeV, and for helium BePn, for helium it's 7 MeV. And what is happening here? Two deuterium combining and forming one helium. So here, like, how many nucleon in deuterium? That is 2, right? How many nucleon? 4. So the energy released, that can be written as 4 times 7 minus 4 times 1.1, and this is 28 minus 4.4, that comes out 23.6 MeV. This is the energy released. So now it's asking, when a deuterium nuclei fuse to form a helium nuclei, when two deuterium nuclei, the energy released in the fusion is, so that comes out to 23.6 mega electron volt. Okay, let me just erase this. Okay, next question number 11. An electron in the hydrogen atom, okay, question number 11, jump from accelerated state n is equal to 3 to n equal to 1 ground state, and the photon thus emitted irradiate a photosensitive material. If the work function of the material is 5.1 electron volt, the stopping potential is estimated to be. So it's simple thing actually here. Electron is jumping from n is equal to 3 to n is equal to 1, so it will be emitting one photon, and this photon is used incident on a photosensitive material. So let's calculate the energy of this photon E. So E can be written as energy like E initial minus E final, that is equal to minus 13.6 divided by n, and like 3 square minus of minus 13.6 divided by 1 square. Simplifying it, minus 13.6, 1 by 9 minus 1. This comes out to be basically minus, will be plus 13.6 into 8 by 9, and multiplying it, it comes basically out to be like 6.9 something, that's alright. It comes exactly like 7 electron volts. So this is the energy of, oh no, just 1 second, it will be 13, let me write it simply, 13.6 into 8 divided by 9. So this is the energy released. Okay, now it's saying the stopping potential is estimated to be, stopping potential will be, so out of this will be the energy of photon. but this total energy is utilized first for ejecting the photon. So means energy, kinetic energy of photoelectron, that will be equal to 13.6 into 8 divided by 9 minus 5.1, and simplifying it, it comes out to around 7 electron volts. So the stopping potential required, stopping potential will be around 7 volt. This is the answer to problem number 11. Next question number 12. A condenser of capacity C is charged to potential difference V1. So condenser of capacity is charged to potential difference. This is C, charged to potential difference V1. The plates of the condenser are then connected to an ideal inductor of inductance. After this, it's connected to an ideal inductor of inductance L. Okay, right. The current through the inductor when the potential drop difference across the condenser reduces to V2. So now it's asking current through the inductor when potential drop across this. Initially potential difference is V1. After it's connected to inductor, the potential difference finally becomes V2. So we can use here conservation of energy principle. Conservation of energy. First thing is, initially when it's connected to a potential difference V1, then energy E initial is half C V1 square. Okay, let's say when C plus L both are connected and current through L is I and potential drop across C is V2. Then total energy will be E final, you can write half L I square plus half C V2 square. And this energy must be equal to this, equal to half C V1 square. Half will cancelled out, and simplifying it, I is coming out to be C V1 square minus V2 square divided by L, and under root over this is giving you I. So that matches with option number 4. That is question number 12. Next question number 13. The thermo EMF E in volt of a certain thermocouple is found to vary with the temperature difference theta in degrees Celsius between the two junctions according to the relation. Thermocouple, you must understand actually, like two metals, different metals are joined at one junction, and when that is dipped in some hot temperature, some current, actually some flow or potential difference is developed across the junction. That is called thermocouple, and the potential difference as a function of temperature is given by 30 theta, where theta is the temperature in degrees Celsius, theta minus this is theta squared by 15. This is the neutral temperature of the thermocouple. Neutral temperature means when potential difference becoming 0, and that's simply 30 minus theta by 15 into theta becoming 0. So one is theta equal to 0, another is theta equal to 450 degrees Celsius. So here option is basically 450 degrees Celsius. Question number 13. Next 14. The magnetic moment of diamagnetic atom much greater than 1 between 0 and 1 equal to 0. This is a theoretical question, standard like just memory based question. So we know already that for a diamagnetic substance or atom, the net magnetic moment for a diamagnetic atom, magnetic moment is coming out to 0, matches with option number 4. Question number 15. Two identical bar magnets are fixed with their center D apart. A stationary charge Q is placed in between. So two bar magnets and as fixed like this with their centers distance D apart. Okay. A stationary charge capital Q is placed at P in between the gap of the two magnets at a distance D from the center O as shown in the figure. So at this point O center, a Q charge is placed from the center as shown in the figure, the force on the charge. So definitely because of this there will be some D, and due to this also there will be some D, so we will have net magnetic field. But remember that this charge is placed stationary, and we know actually due to magnet there is no force on a charge particle at rest. So that's why you can say the force acting on the particle, force acting on Q due to these two bar magnet will be 0, because magnetic force is not applicable, or magnetism or a magnetic field does not apply any force on a stationary charged particle, and that's why the force on that Q will be also equal to 0. Okay, next question number 16. Okay, so next question number 16, a source S1 is producing 10^15 photon per second of wavelength. So S1 is producing 10^15 photons of lambda 5000 angstrom. Another source S2 is producing 1.02 into 10^15 photons per second of lambda 2, that is 5100 angstrom. Then it's talking about then power of S2 by S1. So power we can write equal to, means like total energy emitted, and that can be written as basically number of photons and into energy of one photon, that is Hc divided by lambda 1. So S power of S1, so P S1 by P S2, or it's talking about P S2 by P S1, this will be equal to N2 Hc by lambda 2 divided by N1 Hc by lambda 1. Hc gets cancelled, and this comes out to be N2 by N1 into lambda 1 by lambda 2, and substituting the values 1.02 into 10^15 multiplied by lambda 1 5000 divided by N1 10^15 multiplied by 5100, and this simplifying and or multiplying we are getting it simply 1. So the ratio is 1, that matches with option 1 answer, 1.00 or even right. Next question number 17. Vibration magnetometer placed in magnetic meridian has a small bar magnet. The magnet execute oscillations with the time period t 2 seconds, and we know actually time period is given by 2 pi by omega, and that is equal to 2 pi under root I over mb, where m is the magnetic moment of that magnetometer, b is the magnetic field, and I is its moment of inertia. The magnetic, okay, 2 seconds in horizontal magnetic field. So B horizontal is given at 24 microtesla. Now I'm saying when a horizontal field of 18 microtesla is produced opposite to that to the Earth's field by placing a current carrying wire. So now let's say Earth magnetic field, this is BH, and then we have another B opposite B prime is of 18 microfarad is microtesla is produced. The net B H prime will be 24 minus 18, that is basically simply yes, it's 6 microtesla. Then T prime by T is equal to 2 pi, this is under root I, because I is the magnetic moment, moment of inertia of that magnetometer, that is not changing. We are simply changing only magnetic field, and will be also remaining same. So this can be written as I by mb, like b prime divided by 2 pi under root I by mb. Okay, bh, or this is bh prime. Simplifying it, everything cancelled out, and this comes out to be under root bh divided by bh prime, and this is under root 24 divided by 6, that is 4, and t prime we need actually okay, just 1 second, we check the calculation. So t prime I need, t prime is let me just check the calculation. Okay, so just that's correct all. The like here it comes out to be 1 by under root b, and this implies t prime by t equal to under root b by b h prime, and this is 24 divided by 6. Okay, I already substituted. This is under root 4, that is equal to 2, and t prime I need, so t prime is equal to t multiplied by 2, that is equal to 4 second. So this is the new time period of vibration magnetometer on making a change in Earth's horizontal component by placing one current carrying wire. Next question number 18. Two positive ion each carrying charge Q are separated by a distance t. If F is the force of repulsion between the ions, the number of electrons missing from each ion will be equal to. So here it's simple. F is given by kq square by d square. Kq divided by d square. This implies q square is equal to f d square divided by k is like write 1 by k, and this implies q is equal to 4 pi epsilon naught f d square, and q again at under root, and q is equal to what? It's n e, right? And it's saying how many number of electrons are missing, so that means n is coming out to be under root 4 pi epsilon naught f d square divided by e square. This is answer which matches with option number 3. Question number 19. The potential difference that must be applied to stop the fastest photoelectron emitted by a nickel surface having work function 5.01 electron volt when a ultraviolet light of 200 nanometer falls on it must be. So what is the energy of photon? We can write it. That comes out to be 12,400 divided by 2,000, because it's given as 200 nanometer, is it? So we need to convert, then it will come directly in electron volt. So this, and so it comes out to 6.2, right, electron volt. Then it's saying the when okay, light fall, so maximum kinetic energy of photoelectron, that will be 6.2 electron volt minus 5.01 electron volt, that is comes out to be roughly this is 1.2 electron volts. So stopping potential means it must be negative minus of 1.2 volt. Matches with option number 2. Next question number 20. Okay, next question number 20. So a square surface of side L meter in the plane of the paper is placed in uniform electric field E volt per meter acting along the same plane at an angle theta with the horizontal side of the square as shown in the figure. The electric flux linked to the surface in unit of volt per meter. So here one square plate is given and side L, so its area we can write it simply L square, and area vector will be like a normal to it, you can write, and magnetic field is like this, and it's mentioned that these are making an angle of theta. So we can resolve actually this into two components. This area vector, let's say area vector is along this, then it can be like a cos theta and a sin theta. Like area vector can be resolved in two components, and the magnetic field, or we can write phi, is given by simply b var dot a var, and that comes out to be angle between b and a is theta, so that can be that b a cos theta, and a is given as L square, so phi is coming out to be b L square into cos theta. So that matches with the cos theta. This is the flux through the square loop, and that is matching with option number 2. Next question number 21. A series combination of n1 capacitor, each of value C1 is charged by a source of potential difference 4 volt. When another parallel combination of n2 capacitor, each of value. C2 is charged by a source of potential difference V. It has same total energy stored in it as the first combination has. The value of C2 in terms of C1 is that. Okay, so here N1 like capacitor, each having capacitance C1 connected in series. So C equivalent is coming out to be what? In case of series, it is equal to simply C1 by N1, and it's connected. So I can write simply capacitance C1 by N1 connected to potential reference of 4V. So energy stored E is equal to half CV square, that is half C is 1 by N1 into V square, that is 16, 4V whole square, that is 8 C1 V square divided by N1. This is the energy initially stored. Next it's saying, okay, when another parallel combination of so parallel combination of N2 capacitors of capacitance C2, is it, then C equivalent is equal to N2 C2, and this is connected in parallel with a N2 C2, then energy E2 is equal to half CV square, again half N2 C2 into V square, and it's mentioned this energy total stored and this energy stored is equal. So this implies E1 equal to E2, that implies 1 by 2 N2 C2 V square equal to 8 C1 V square divided by N1, and just getting it, V square gets cancelled out, and C2 is coming out with 16 C1 divided by N1 N2, and that matches with option number 4. This is the answer to question number 21. Next, question number 22. Okay, a square current carrying loop is suspended in a uniform magnetic field acting in plane of the loop. So square current carrying loop, let's say carrying current in this direction of I, and uniform magnetic field in acting in the plane of some uniform magnetic field is acting in the plane of the loop. Then we can say with force on one of the arm is F, then the net force on the remaining 3 arms. So the thing is that when a loop is placed in uniform magnetic field, net force on that must be 0, is it? Net force on a loop in uniform B equal to 0. This implies if on one arm force is, let's say, F bar, then plus on remaining part it's, let's say, F1 equal to 0. This implies F1 is equal to minus of F bar, and so answer is 2, that is minus like F bar. Consider the following 2 statements. Kirchhoff's junction law follow from the conservation. Okay, so this is also, you can go it like question number 23, theoretical questions that we when we study the Kirchhoff's law, then we see these like statements. Kirchhoff's junction law followed from the conservation of charge. Yes, junction law, net charge is conserved. Whatever the charge coming at the junction must be equal to the charge going, or rate of charge, we call it current. So Kirchhoff's junction law follow from the conservation of charge, that's absolutely right. Kirchhoff's loop law follow the conservation of energy. Yes, that is also correct in a loop. Which of the statement is correct? Both A and B. So here like both A and B both are correct. Fourth is correct statement. A ray of light traveling in a transparent medium of refractive index mu fall on the surface separating the medium from the air at an angle of, so this is let's say mu air transparent traveling, and this angle is given as 45 degree. Okay, for which of the following value of the mu the ray can undergo a total internal reflection? So that means mu sine 45 degree must be equal to 1 sine 90 degree. Minimum condition for the TIR, and this implies sine 45 degree means 1 by root 2 r into mu should be equal to 1, and this mu should be equal to root 2. And another thing is, here we know sine theta must be greater than this, is it? So that implies you can write for which of the value of me can undergo total internal reflection. So mu in like we can write normally theta c is coming out to be 1 by mu, and we know theta should be greater than theta c. This implies theta should be greater than 1 by, means I can write theta c is equal to how much? Theta c is equal to 45 degrees. So we got, first thing is mu is equal to root 2, and theta must be greater than theta c. So this implies theta must be greater than what? 1 by root 2, or simply just we write it actually here. Okay, just one thing. So here one thing is that mu is coming out to be root 2, right? So for this condition, when angle of incidence is 45 degree, for mu is equal to root 2, there will be TIR. Now what is given here is we are keeping the theta 45 degree constant, and we want the TIR to happen. So in this situation, what will happen actually? If mu is higher, right, then critical angle will be even smaller, is it? If mu is greater than mu, like let's say naught, then theta will be less than theta c. And if incident angle is, let's say now theta c is becoming 30 degree, but still ray is incident at what? 45 degrees. So in that case also TIR will happen. If mu is less than this, then what will happen? Theta c will increase. Theta c will become, let's say, 60 degree. Now if theta c is 60 degree and ray is incident at 45 degree, in that case TIR will not happen. So for TIR to happen, we can write mu must be greater than root 2, and this implies mu must be greater than 1.41, and the greater than 1.41 option here is only one, that is 3. So mu is equal to 1.50, that is the correct option here. This is question number 24. Okay, next question number 25. So it's saying efficiency. So let's say here what is happening, one is battery internal resistance, and this is the external resistance, capital R, small r, and battery E. I in the circuit is given by E by capital R plus small r, and power supplied by the battery, is it? Power by battery can be written as E into I, and power consumed in the resistance is equal to I square into R, and efficiency eta is given by P in R divided by P by battery multiplied by 100. Clear? So this substituting it, P in battery, I square into R divided by E into I multiplied by 100, and this is equal to 1 I gets cancelled. So this is I R divided by E into 100, and it's given initially, this is the situation, it's given as 60%, so means 60, and I can be written as this, so it's coming out to be E into R divided by E into R plus R multiplied by 100, that is 60, and E gets cancelled, so this is R divided by capital R plus small r. This can be written as 0.6 also. Okay, and then from here we can get the value of actually capital R by small r, or we can get the value of, and next thing is what is happening, this is replaced by 6R, then eta will be equal to what? 6R divided by 6R plus small r, because what is changing? Rest remaining things are remaining, everything is remaining constant, only R is replaced by 6R. Substituting and simplifying it, we get here actually eta is equal to 90%. This is answer to question number 25. Next go to question number 26. Okay, two coils connected in series have resistance. So two coils connected in series R1 and R2 connected in series, and 600 ohm resistance, 300 ohm resistance, and at 20 degrees Celsius, the temperature coefficient, so alpha, let's say this is 0.001 per Kelvin, and alpha 2 is 0.004 per Kelvin. This is alpha 1, alpha 2. The effective temperature coefficient of the combination in series. So we can write R equivalent is equal to what? 300 plus this is 900. If alpha equivalent is, let's say, alpha, then I can write R is equal to 901 plus alpha into theta. Clear? This would be equal to 601 plus alpha 1, 0.001 into theta, plus 301 plus 0.004 into theta. Clear? Just simplifying it, 300 is all cancelled, and this 1 gets cancelled, and theta also gets cancelled. Simplifying it, and we are getting it basically here that effective. Okay, we need actually here. So here I can write 9 alpha is equal to how much? Okay, I can cancel it with 3 also. So this is 2 and this is 3. Then it comes out that 3 alpha is equal to how much? 0.002 plus 0.004, and this comes out to be 0.006. One more, so it's coming out to be 0.002, and alpha that can be written as 1 by 500 per degree. Is it per degree? This is the value of alpha, because everything is in degree, and that matches with option number 3. Question number 26. Next, question number 27. Okay, potentiometer wire 10 meter long and 20 ohm resistance is connected to a 3 volt battery. Potentiometer wire, 3 volt battery, internal resistance, and this is a potentiometer wire. Some resistance and length is given as 10 meter. Resistance is given as 20 ohm, and this is a 3 volt battery and having resistance 10 ohm. So current I is equal to how much? 3 divided by total resistance, that is 30, that is 1 by 10 ampere is the current in the circuit. Alright, the potential value of potential gradient, so V across wire is given by what? I into R, so 20 divided by this is equal to 2 volt. Potential difference across the potentiometer wire. Then potential gradient is given by potential difference divided by V divided by length, that is equal to 2 divided by 20, that is 0.01 volt per meter. This will be the answer. That matches. Just 1 second. This comes out to be 0.2, and length is 10 meter only. So this comes out to be 0.2. So that is equal to 0.02 volt. Just 1 second. 0.2 volt per meter. This is the answer matching with option number 2. Question number 28. So here, a conductor with rectangular cross section has dimensions this as shown in the figure. Resistance across AB is X, CD is Y, and here it's simple, straightforward question 28. So things are given like this, and it's given as 4A. This is given as 2A, and this is given as A, and now here A, B, this is C, D, and across this is E and F, right? Resistivity, let's say it's rho, so we can write R, AB will be equal to, if it is AB, then this will be the area of cross section, then rho A by L, and length will be this. It comes out to be rho A is area is 2A squared divided by L is 4A, so it comes out to be 2 into A, RAB. Similarly, RCD is comes out to be rho, area is 4 into 2, so 8 divided by L, so 8A by, this is RCD. Rho area is equal to this multiplied by that, so 4 into 2, 8, A square divided by length is 8, that is, and R here EF will be equal to rho into area, 4A square divided by length is 2A, that comes out to be 2 rho A, so REF. And this is Z, this is Y, this is X. So which one is major? Higher. Here it's like we can say, right, just resistance across AB. AB is given as X, that's resistance across CD is given as Y, CD is given as Y, and resistance across EF. So EF is given as, alright, Z. Okay, so resistance across EF, let me just check the calculations. 4 EF, 4A square divided by rho A divided by L, that is 2A, and 2 rho A, and that's correct. So here we can say Y is greater than Z is greater than X. This is the relation, Y greater than Z greater than X, that is matching with option number 3. This is answer to question number 28. Okay, next question number 29. So here one circuit is given. So if the reading of ammeter A1 in the figure is 2.4, neglecting the resistance of the ammeter, the reading of ammeter A2. So here we can see actually one resistance, and then its current is divided into two resistance, let's say R1 and R2. Here it's given as A1 and here it's A2, and we know the current I1, I2. So when it's dividing actually across two resistors in parallel, then I is inversely proportional to R. So we can write I1 divided by I2 will be equal to what? R2 divided by R1, and I1 is given as 2.4, let's say I2 is I, and R2, this is all given to us. So this is R2 is 30 divided by 20, and simplifying it, this implies I2 is coming out to be, this is 2.4 divided by 3 multiplied by 2, that comes out to 1.6 ampere. This is the reading of ammeter 2. Next question number 30. Cell having an EMF E, internal resistance R is connected across a variable external resistance R. So cell, internal resistance connected across a variable resistor, capital R. Then, as the resistance R is increased, the plot of potential difference V across R is given by. So here V across R is given by E divided by capital R plus small r into capital R. Right? And we can check it. So definitely this is not appearing like a straight line. When we can check if R is equal to 0, then V is coming out to be 0, so it will be starting from 0. And as R tending to infinity, okay? So R tending to infinity, then dividing it by R, then comes out to be almost E. So we can then say it will be like increasing, and as R tending to infinity, it will be E, and this is your capital R. So my option matches with like third. Next question number 31. A potentiometer wire of length L and capital resistance R are connected in series with a battery of EMF E0 and resistance R1. So battery of EMF E0, resistance R1, and potentiometer wire of length L, resistance R. Alright, so that means I is given by E0 divided by R plus R1. Okay, and now it's saying an unknown EMF E is balanced to a length of L of potentiometer wire, the EMF. So E is directly proportional to what? I into resistance, let's say R prime, and R prime is equal to what? It's given as length L, so I can write it's R divided by L into L. Right, so E, I can write I into R prime, and E is equal to I is E0 divided by R plus R1 multiplied by this, that is R divided by into L divided by capital L. This is the answer which matches with option number 1. Next question number 32. Figure shows a graph of current I flowing through a cell against its terminal voltage V, the EMF and internal resistance of the cell. So EMF means it's here I versus like V versus I graph is given. This is V versus I graph. We know EMF is what? When current through the battery is 0, then potential difference across it is given as EMF. So current 0, then EMF is, so you can write EMF potential difference, that is equal to 1 volt. And the next thing is the EMF and internal resistance of this cell. So when like maximum peak current is flowing, then we can write potential difference delta V is equal to EMF minus I into R. R is the internal resistance. It's given as, it's coming out to be 0. So this implies I is given as 4 ampere. So small r is equal to 1 by 4, that is 0.25 ohm. This is internal resistance that matches with option number 1. Potential 1, EMF 1, and internal resistance 0.25 ohm. Next question number 33. It's a good question actually. Here two capacitors, resistor connected like this, and one resistor connected in between in this manner. And here this is the system of 1 ohm. This is 4 ohm, 4 ohm, 4 ohm, 3 microfarad, 3 microfarad, 3 microfarad. This is the 3 microfarad. You can check the diagram in the problem. Okay. Now on each of the capacitor, charge in steady state. So see, the thing is that in steady state there will be no current across this, no current across this, but there will be current in this arm. So I can be written as basically E. EMF is given as 10. So 10 divided by 4 plus 1, 5. So that is equal to I is equal to 10 by 5. That is equal to 2 ampere. Right? And current, so that means potential difference across this is equal to what? Potential difference across this. And that is equal to, so V is equal to 8 volt. I multiplied by R. And I can add this V will be equally divided because no current is across 4 ohm. So it will be 4 voltage across this, 4 voltage, and across this also 4 voltage. Then it's saying energy stored on each capacitor state in steady state. So E is equal to half CV square. C is 3 into V square, that is equal to 16. Like, because 1 it will be divided equally, right? So that comes out to be just 1 second here. Alright. Just 1 second. Actually, it's talking about charge stored in each capacitor in steady state. So total 8 voltage is the potential drop across these two. So across each capacitor, potential drop is given by 4. Then Q is equal to simply CV, that is equal to 3 into 4, that is equal to 12 microcoulomb. Actually, I was calculating the energy stored in the capacitor. So charge will be simply coming out to be 12 microcoulomb. Next question number 34. The radius of circular plate of parallel plate capacitor is capital R, and air is the dielectric medium between the plates. If the capacitance of the capacitor is equal to the capacitance of the sphere of radius capital R, then the distance between the plates is. So let's say here we have a parallel plate capacitor where like plates are circular. Then radius is given as R, and let's say the separation between them is D. So C is given by A. Epsilon naught, area is pi R squared divided by D, and capacitance, this is equal to capacitance of a sphere of radius R. So that is equal to C sphere is given by 4 pi epsilon naught into R, and these two are equal. So this implies pi gets cancelled, epsilon naught gets cancelled, 1 R gets cancelled, and this implies D is coming out to be R by 4. This is the separation between the plates of circular plates of condenser or capacitor. Okay, next question number 35. So here it's given a current I is flowing in a straight conductor of length L. I is flowing of length L, and from its center at a distance of L by 4. So this is a finite wire. Let's say this is angle theta, this will be also angle theta, and this length can be, this is L by 2, this is L by 4, so this is under root 5 L by 4, and then sine theta is coming out to be L by 2 root 5 L by 4, that is equal to 2 by root 5. And then B, due to this system, is given by mu naught into I by 4 pi R. This is R into sine theta 1 plus sine theta 2. In this situation, both theta 1 and theta 2 are constant. The magnetic induction at a point distance L by 4 from the center, so that means symmetrically, so both theta will be equal, and this implies B is given by mu naught I 4 pi R is L by 4 multiplied by 2 into sine theta is 2 by root 5. 4 gets cancelled, so B is coming out to be 4 mu naught I divided by pi root 5 into L. This is the answer to problem number 35, matching with option 1. Next, question number 36. So here it's saying, in the following figure, 3 parts of alpha particle crossing the nucleus are shown. We know actually nucleus is having positive charge and alpha particle is also positively charged, so repulsion must be there. And the correct path is, so one is, if it is directly trying to hit the nucleus, definitely there is possibility of bouncing back with 180-degree angle. And second case, B, it's getting sort of attracted towards the nucleus, that's not possible. And yes, if it is like nucleus and it alpha particle is bombarded sidewise, then it will try to repel from it, so definitely it will be it can go possibly in C option also. Then possibly the correct option are like paths are A and C, and the option matches with 1. Question number 37. Water flow through a non-uniform tube of cross section ABC whose values are 25, 30, 15 and 35 centimeters square. The ratio of the velocity of water at section ABC. So here A, B, C, area 25, 15 and 35. Let's say velocity V1, V2 and V3. So by continuity equation we can write A1 V1 equal to A2 V2 equal to A3 V3. So let's say initial for this velocity is V1, then I can calculate V2. So this is 25 V1 equal to 15 V2. This implies V2 is equal to 5 V1 by 3. Similarly, I can write this by comparing these two equal to 25 V1 is equal to 35 V3. V3 is equal to 5 V1 by 7. Right, and then this V1 is to V2 is to V3 equal to, this is V1 and this is 5 V2 by V1 by 3 is to 5 V1 by 7. Right, just taking LCM, this comes out to be 21 is to 35 and is to 15. This is the answer which matches with option number 3. Question number 37. Next, question number 38. A liquid is kept in a cylindrical jar which is rotated about the cylindrical axis. The liquid rises at its end. This is a standard formula actually, rotation of cylindrical jar in this. If it is filled up to here, on rotating it comes in this direction. R radius or height y at radius r is given by y is equal to r square omega square by 2g, and this will be the also difference in height, so delta h is equal to r square omega square by 2g. That matches with option number 2. Question number 39. Force of 10 Newton is required to draw a rectangular glass plate on the surface of the liquid with some velocity. Force needed to draw another glass plate of 3 times length and 2 times. So we know actually it's a viscous force, and that's given by eta A dV by dy. Now in next case, what is given as, in first case it's given as 10 Newton. In next case F2, we are eta is remaining same, area length becoming 3 times and width becoming 2 times. That means area is becoming 6a times into dv by dy. Remaining things are all constants, so 6 multiplied by 10, that comes out to be 60 Newton is the answer to question number 39. 40. The length of rubber cord floating in water is 5 centimeter. Force needed to, so here you must understand actually what is exactly happening. Rubber cord and this, and it's floating on surface of the water. So what will happen actually? Water surface will be like pulling it from both sides like this. So the force required F is equal to T multiplied by 2L. This is 7.2 into 10 to the power minus 2 multiplied by 2 into L is 5 centimeter, that means 0.05. so this comes out to be 7.2 into 10 to the power minus 3 Newton will be the answer that matches with option 1. That is question number 40. Okay, next question number 41. So it's asking calculate the force required to separate the glass plates of 10 raised to power minus 2 meters square area minus 2 meters square. You need to understand exactly what is happening here. So the glass plate, the liquid will spread like this and this form one cylindrical surface. So P inside and it will be P outside. P outside minus P inside, this is axis pressure, and that's coming out to be here in case of cylindrical it's divided by R, and this is the R, that is equal to, if T is the thickness of the, then R is equal to T by 2. So delta P is coming out to be 2T by T. Capital T is the surface tension. Then this is the axis pressure here, so it will be applying force to push this side. So to separate them out, force required F prime F external, that is equal to delta P multiplied by area. Substituting the values, delta P 2, 10 surface tension is given as 25 70 into 10 to the power minus 3, area 2T divided by small t is 0.05 into 10 to the power minus 3 into area is given as 10 to the power minus 2. This cancelled out, power, this is also gone, and simplifying it, okay, 28 Newton, this is the external force required to separate the plate. Simplifying it, we are getting 28 Newton. Next question number 42. Work done in increasing the radius of soap bubble from 4 centimeter to 5 centimeter in joule. So here we need to understand work done in increasing this radius means we need to increase the surface area. So work done is on that too, remember it's bubble, it's not drop. So W is equal to tension multiplied by change in area, and that's equal to tension multiplied by 4 pi R final square minus 4 pi R initial square multiplied by 2 because it's bubble. So simplifying and substituting the, this is T into 2 into 4 pi into 5 square minus 3 square into 10 to the power minus 4, right, minus 4 to convert this centimeter into meter, and then substituting all the values. So this W is equal to 2 multiplied by surface tension is 25 into 10 to the power minus 3 into 4 pi multiplied by, this is 16 minus 9, 25 minus 16, that is 9, that is equal to 16 into 10 to the power minus 4, and that's all. Simplifying it all, W comes out to be 0.5657 into 10 to the power minus 3 joule. That is the work required to be done to increase the surface area of the soap bubble from increase the radius of the soap bubble from, right, I did mistake actually, it is a 4 square and radius final, and that's all the calculation here, because 16 this is will be 9 actually, and I have just done that calculation already, checking it, simplifying it, it exactly comes this way. Next question number 43. A mercury drop of radius 1 centimeter is sprayed into 10 to the power 6 drops of equal size. One bigger drop spread in small drop. by conservation of volume, 4 by 3 pi r cube is equal to n into 4 by 3 pi r cube. This implies n, r is coming out to be r divided by cube root of this. That substituting the values, it comes out to be r is 1 centimeter, 1 into 10, 1 by 10 to the power 2 centimeter. This is the final radius. Now the energy, okay, expanded in joules. So energy we can write E is equal to change in area, again surface tension multiplied by delta A. So here area is increasing, so energy will be like required, is it? So yeah, right. So it's a mercury drop of radius once sprayed into this equals as the energy expanded in joules. Surface tension of the mercury is given as, so this is surface tension 460 multiplied by 10 to the power minus 3 into, this is a final, this is n multiplied by 4 pi r square minus 4 pi capital R square. We can substitute the values. So this is 460 multiplied by 10 to the power minus 3 into 4 pi into, this is r square, n into, this is capital R square divided by n power 2 by 3 minus capital R square, right? And this is 460 into 10 to the power minus 3 multiplied by 4 pi, this is n raised to power 1 by 3 into r minus 1 into r square. We have here everything. Actually we can substitute the value and simplify it. On substituting and simplifying it, here we get energy is coming out to be 0.057 joule. This is answer to 43. Next question is 44. Just substitute and check the calculation. The diameter of brass rod is 4 mm and Young's modulus of the brass is, so diameter is given as 4 mm, Young's modulus is given as 9 into 10 to the power 10 Newton per meter square. Young's modulus. Force required to stretch by 0.1% of its length. Delta L by L into 100 is 0.1%. So delta L by L is coming out to be 0.1 divided by 100. And this is also equal to strain, and we know actually stress upon strain is equal to Young's modulus. This implies force is equal to Y epsilon into area. Y is given as 10 to the power 10 multiplied by 9 into epsilon is given as 1 by 1000 multiplied by Y epsilon area. Area is pi into d square by 4. So F is equal to 9 into 10 to the power 10 divided by 10 to the power 3 multiplied by pi by 4 multiplied by, this is d. D is given as 4 mm. So 4 into 10 to the power minus 6, right? So then simplifying it, 4 pi d square, so means one more 4. This cancelled out, and power 9, it's like this, and 36. F is equal to 360 pi Newton. So this is answer to question number 44. Next question number 45. So the temperature of a wire of length 1 meter is increased and area of cross section 1 centimeter square is increased from 0 to 100 degrees Celsius. Temperature is increased for question number 44. Okay, if the rod is not allowed to increase in its length, then the force required, so it's a thermal stress basically. We can calculate delta L is equal to 1 L alpha delta theta, change in temperature. Strain delta L by L alpha delta theta, and stress is equal to Y into strain, so Y alpha delta theta. It's asking about the force. If the rod is not allowed to increase in its length, force required, so F is equal to Y epsilon A, that is equal to Y A alpha delta theta. Now I can substitute all the value. Alpha is given as 10 to the power minus 5, Y is given as 10 to the power 11, Y alpha area is given as 1 into 10 to the power minus 4, and delta theta is given as 100. Simplifying it, 10 to the power minus 4, 5, and this comes out to be 12 into 13 and minus 9, so 10 to the power 4 Newton. That is answer to problem number 45, matches with option V. So this is all about question like this paper DT 09 for NEET. I hope all your doubts would be clear, and that's all. Thank you so much.